G'day YouTube, JB from Oz here. So today it's time to christen the laser after I've done an alignment test with a job for Emma Ritson from Emma's Spareroom machine shop. One of the things that Emma has recently shown a video on is how to do a hand scraping of a surface plate that she and Chris Anderson were working on together. And she got a casting when she was over at the bash, Barzi's summer bash last year, and she hand scraped that in and she's made a label for it. And one of the things we spoke about was making a box for her to keep that stored in. So she roughed up some ideas as to what she thought she wanted to achieve, and she sent those drawings across to me, and I've now gone through and proofed up a design that I think we should be able to laser cut. So essentially I've brought the design in. I've used a program called Box Designer. It's a free utility on the internet. And I've then come through and I've added some details to allow us to have these two sections tabbed into the back of the box and the bottom of the box, cut through the two side panels so that we have the top, the lid, and the top and the front. And then the back, the two sides, the bottom and the front bottom. So let's throw these in the laser cutter and see what they look like. So prior to preparing the file for cutting, we need to know what speed and feed we should be using, or what power and feed we should be using. And I've just done a cut test on the four corners of the bed, just a little test, 10mm or 20mm square with a 10mm hole cut out of the bottom of it to make sure that we had good penetration across all corners of the bed. This is the material that we're going to use for the box. It's just a bit of standard ply from Bunnings. Putting it face down so that the bow in the material helps to hold it mostly flat. And yeah, that's the design. So back before I had done a proper alignment on the laser, I was using this laser at 90% power at 8mm a second to cut through 3mm MDF. And we've got a power control knob that allows us to back off from that. The most recent test cuts that I've done with this 20mm square, I'm using a 6mm speed and a 90% power to go through 7mm of ply, so over twice the thickness and at 80% of the speed, so, or what's that, 75% of the speed. So the alignment has done very well in terms of focusing the beam and getting us the result we need. So we'll now do a new file and import our cut. So we're looking for Emma's box, there it is. Now one of the things to notice is it has brought in the guides, which is not something we want. So I'll get rid of those. I'll come back once I've done a bit of a clean up. Okay, I've done a bit of tidy up. With this particular piece of software there's a bit of fiddling to get the cut path ordering working correctly. Things such as layers are not automatically handled well. And sometimes the only way to do it is to actually do a cut optimize using the order of the layers and explicitly calling out the center components before cutting the outsides. So that's how I've configured this now. Everything else is just an outside shape. So we should now be ready to download the cut file to the laser. Alright, moving to the laser. Next thing we need to do is align to our start position. So typically what we'll do is physically place a board in the machine to a frame, which makes sure that we are clear of any existing cuts and that we're all on the board. That's looking good. With some of the cheaper plywoods there can be voids, so it's going to be pretty important that I hang around and watch this cut. Now, bit of noise. Secondarily, we've got a industrial chiller here, and the job here is to maintain the laser temperature, the cooling temperature, at an appropriate value. Okay, so we're definitely getting some temperature rise out of the cooler. It is a chiller, so there is a refrigerative element to it, but it is struggling. And it's been running at maximum power now for 22 minutes. So it's probably worth, I'll just do some checks on the coolant level before I run too many more long cuts. Alright, so 30 minutes later, the cut is completed. Temperature's starting to come down, so that'll just help to cool the tube down before we shut it down completely. At the moment I've got the chiller and the exhaust fan on the same circuit, so I'm considering possibly separating the two of those so that I can shut one down without the other, just to deal with the noise factor. So it's pretty neat. Don't tell me, you bugger. So we've got one spot that hasn't cut through up there. I must say I was running it at a pretty fair clip, so some setup issues. I had a couple of parts that cut twice and a couple of parts that didn't quite make it all the way through. So the parts that cut twice, including these plug holes, I'm recutting, and also this piece here that didn't cut completely, just in that one section, I'm recutting. There he's now zooming along. Should have a chance to see the final construction very shortly. There's a couple of pieces just test fitted together. Of course, the fit's really nice.
Hey, job done.
So the second cut took us another 14 minutes. Laser's back up to 29 degrees. I think that should be alright. Time to cut the noise out. Okay, so here we have it. The finished Ritson box. Box is designed to have two small hinges, so there's clearance holes for two hinges in the back there. There's a bit of extra surface left on there to just do a sanded finish once it's glued together with the wood glue. Box lid is expected to open up like so, revealing the surface plate inside. and I'm not sure if Emma's thinking of a catch or a latch. We initially discussed possibly using one of the latches I used on my living hinge box designs, but as a first prototype I think we're somewhere near it. And then the surface plate sits down inside, 2 handles for the plate to sit upon. There you go, mate. Hope that's somewhere near what you had in mind. One of the other ones that's rapidly approaching production ready is the BA Buddy, and this is what I sent through to Steve Lang as a part of the YouTube Machinists group Christmas Secret Santa. And I don't know if you can quite make it out there, it's quite fine. I was trying to figure out how to do such a fine pitch to be able to determine what the pitch on a 10 BA metal bolt was. So I've essentially gone with just a sequence of cut lines so that the crests of the threads would intersect with one of these, and then you'd be able to tell pitch across threads of a 0 to 10 BA. Tap drill sizes, because the tap drills for BA are all over the place. There's number drills, there's imperial drills, there's metrics. Essentially I've got a box of drill bits and I'll just poke around till I find one somewhere near it, drill it out. If I'm a bit undersized, you know, a couple of extra sweeps with the drill, see if I can't open it out a bit. So we've got a tap drill size, a clearance drill size, and the head of the bolt, the hex. So if you've got a bolt and you want to say what is it, you put your head in, you can see, oh, it's a 3BA, and you can drill a hole, tap it and so forth, or you can identify the thread from marking against it. This is one I'll have on Etsy, fairly short reference. This is the ER11 living hinge box that I made to hold my ER11 collet sets, and the design is such that the lid latch is closed. The timber itself and the way it's cut is what gives us the lid. And the labelling, of course, so you know which one you've got if you need it. Yeah, another job moving on.